Welcome back to your favorite robotics design tutorial series. So now continuing on, we'll be designing, a claw mechanism to pick up the tesseract, right? So the first thing we'll do to design our claws, we're gonna first put a base on top of this chassis, more like a lid, so that it has, a place to, sit on, right? So in order to do that, we're gonna put some mounting holes on the actual chassis frame, and then we'll screw on a plate on top of that essentially. So let's just start with this and put some holes here, right? So we'll use some M4 screws, and we'll use some heat set inserts in right over here, right? So the heat set insert size for an M4 screw for the inserts we have is 5.6 millimeters, so we'll just put that right there, right? And to be honest, we'll want this, kind of centered. Actually, neat little trick, we could make a rectangle, and let's just put an arbitrary 168 millimeters. It kind of just has to be roughly in these corners, right? And then we can make a line here, a reference geometry, right? I mean, all of this is reference geometries, right? And then make all this hidden, or construction lines, because it's all reference. And then what you can do is just put this into the corner with a coincident constraint right here, right? And that'll put that to there. And we can do that with all the corners, right? Make the same circle in each corner of the rectangle, and that's perfect. Right over there. And over here, oops, I missed it. Right over here. Brilliant. Okay, now let's just finish out the sketch and extrude. It's just not that much. Honestly, 10's pretty good. We'll leave it at that. So there are our mounting holes. And now we can put a little plate over this. Now the easiest way to do this actually is, okay, we're going to start with a new file. And one neat thing about Inventor is, so now, when designing our chassis base, the thing is, sometimes we may want to change some dimensions, and we want that to, follow through on other parts. So one way we can do that is to derive a part, right? Okay, actually, let's go back in here. We can derive our base into this part, right? So we're on our new part that we're going to make our lid in, and we can import this chassis base into here so that we can match up all the geometries. So if we go in here and say, project a good bit of everything, good enough. It's a bit, I don't really need these, but whatever. I also don't really need these. Yeah, sure, whatever. Good enough. I actually also don't need 1, 2, 3, and 4. Yup. So the first thing we can do is extrude out all of this and just delete it, right? Because, we don't want the base to be literally our lid. But another neat feature is that you can share a sketch. So you can use a sketch for multiple things. Also, I did not make these hidden lines, is what I realized. Let's fix that. Construction. There we go. There we go. Okay. Anyways, as I was saying, so we can reuse the sketch to now make our lid. Right, so we can do a bit of this. So to make this lid, actually, there are 1 or 2 manufacturing options we could use, right? So it doesn't have to be a 3D printed part. We can also make this out of aluminum, right, to make a more rigid lid and a more rigid base for our claw mechanism and an arm mechanism and all of that, right? So if you want to go for something like that, try it out. You can make it out of a more standard aluminum sheet size because, when we're CNC machining, right, we're making it out of a specific material that we have to get beforehand, and that comes in, common standardized sheet sizes that are usually in imperial sizes, because, we live in America, so like 1/8 inch would be a common size, or like a 1/4 inch. We have a lot of 1/8 inch material actually for you guys to, use. So if you design stuff, I would recommend making it 1/8 inch thick. So yeah, that's what we'll do. And of course, if you want, you can make this part 3D printed if you so please. But anyways, yeah. So there's that. We have that. So I'm gonna hide the sketch now that we're essentially done with it. Right. And one thing I'll just quickly do is I'll save this up in chassis. And chassis lid is what we'll call it. That did not work out. Chassis lid. Did save. That did not work out as well as I intended. Let's check the folder. There is nothing there. Let's save this. See how that goes. Hello. Chassis lid. Name's an open document. Okay, let's just try a different name, because I actually, what I did is I tried recording this video earlier and I made this file earlier and I deleted it, but clearly didn't delete properly. I got interrupted in the middle of recording this, so I just kind of restarted. Lid chassis. Brilliant. Okay, anyways, now that we have that done, let's just quickly update you. Brother, what is wrong? Delete. Oh, I had this hidden. Okay, so if I delete you, nope. Okay, that should be fine. Okay, so yeah, what happened was I still had the chassis lid in this file, even though I deleted it out of my folder structure, which meant it still existed. Yeah, anyways. Now that we solved that, let's just import that in. Just gonna navigate my way here. And we're gonna see if this fits in. We're actually gonna delete this in a second, because we're gonna actually take this and make its own sub-assembly with just the claw, and then we'll assemble this whole thing together. Just, keep things, organized and clean. Okay, but anyways, let's just check this out. That fits. Looking nice, looking sturdy. Great. But one thing to note for this design is if we're going to make this out of aluminum, and we're going to use a CNC machine, a CNC has certain limitations in its manufacturing abilities. One thing is it can't do sharp inner corners, because I can do a little demonstration actually. Is let's say he's trying to cut this out, right? And let's just project this here just for visuals, right? So we'll make a little circle, and this can be the bit. I use a 1/4 inch bit usually. So let's say we have this guy. He's coming around, right? He's essentially, how a CNC works is that you have a machine with a bit on it, and it cuts the material out, right, from the part essentially. So this is our bit, right? It's in the material. It's cutting it all out. It's on the edge. It's going here. It's cutting it out, and I'm at this corner now, right? And there's still this material here. If I try to cut it out, well, guess what? I'm cutting into this material, and I want this material to be here, right? So I can't just whoop, because then all of a sudden, all of this is gone, and well, I don't want all of that to be gone. So what happens is that I just can't make a sharp corner. What I have to do is, come here, stop, and go on, and I'm just going to have a bit of a round there. And that's just how it's going to go. So what we have to do is just design around that simply. Nothing else you can do. Let me just undo all that. And so what we'll do, actually, I'm just gonna update it on this one. Why not? Because again, we have everything linked, so might as well kind of keep the symmetry and keep everything looking the same. There is more than enough on wheel clearance that it's fine. Anyway, so yeah, I'm gonna add those rounds in. Even if I don't, technically would automatically add it, as in like when I go to machine it, the bit would just make the round. But it's better to define these things, because then we have better tolerance parts that are more like we'd expect them to come out. And our CAD shows us then everything's also modeled in our CAD, and it's more detailed, and we know what to expect spacing wise, right? If we actually go through with CADing these fillets, even if the part would come together without doing so. So okay, did okay. I made them 4 millimeters because a quarter inch is 6.35 millimeters, and so half of that will be 3.175 millimeters, and 4 is a bit bigger than that, so it gives a bit of like clearance room to make a nice corner. Though in this case it's not that important, it's just the corner of a cutout for the wheels, but it's good practice. Anyways, let's update this part. I think it's this one. Okay, so when updating that, it filled in those. So sometimes you need to edit that out, know where it kind of messed up a little bit. But essentially, since the geometry of this changed, it didn't recognize that it was the same geometry and didn't extrude it out. So we had to go in and so essentially it had this selected to also be extruded along with all this material, when in reality we actually had that omitted from the extrusion. So in order to remove something, you just control click on it, or well, shift click. Either does the same thing. Anyways, yeah, we'll save that and we'll move on. Yep, so now on to claw designing, right? Let us see. First of all, which side's the transmitter side. Yeah, okay, so this is a transmitter side. This is where we'll actually be, putting the claw. So for our claw, we'll actually be doing a sort of thing where we have two gears that are meshed into each other, and they're going to be actuated by one servo. Right, so what we'll do is we'll actually start with a new assembly, because we have some gears that we'll make. And the fun thing about Inventor is that they have a built-in way to just make gears, and they generate them for you. But first things first, actually, I'm going to go into a new part and just sort of describe the kind of claw we're making in the sketch. So we have gear number 1, we have gear number 2. They are the same size and they are meshed to each other. They're here and here, right? So for a little bit of review for those of y'all who do not know what a gear is, well, I'll actually just have this make a gear for us really quick. Claw, gears, whatever. Let's go up here. Actually, let's make a new folder called claw before we save this. Yeah. Okay, let the menu load, hit OK. Yay. Alright, so, anyways, these are gears. Essentially what this is, it's a way of transmitting power. So, first things first, let's just kind of put on the edges. So essentially when this top gear spins, it causes this bottom gear to spin, right? And yeah, I mean, it's nothing crazy. There are a few things that go into designing a gear train and a set of gears. But what we're doing is we want this motion to mirror its motion to the other side. So if we have, you know, a gear with, let's see how many teeth are on here, 13 teeth, and we have another gear with 13 teeth here, right? When this makes one full rotation, this other gear will make a full rotation, essentially, right? Now, something neat about gears actually is you can use these to, change how fast something's going, because let's say, you're controlling the amount of rotations this is doing, right? And the number of teeth define how many rotations they do, because each tooth contacts the next tooth. So the idea is that if you have like more teeth on this one and less teeth on this one, let's say I change this. Let's make it woo. Woohoo. Okay, let's say I got more teeth here, less teeth here. If I spin this once, it'll spin this a lot because it's tooth by tooth. So 1, 2, 3, 4, 5. When it goes through these 5 teeth, or what is there, like 6, 7 teeth on this one gear. So 1, 2, 3, 4, 5, 6, 7 teeth all over here, right? It does this many teeth. It turns by this much. It'll turn this whole gear down here, right? So that's a concept called gear ratios. If you're taking Mech 101, you're probably pretty familiar with this. But anyways, we're not really using that today. We're gonna have a 1-to-1 ratio because you want this motion mirrored. So anyways, yeah, why do we get into all of that? Let us explain. So now, after this, we'll have a little, claw here. We'll go, yeah, something like that. And, that'll kind of get mirrored on the other side. Yeah, right over there. And so when this guy spins, this guy will also spin, and it'll be able to pick something up. And this one will be moved using a servo, which is, provided in your kits, right? So anyways, let's get into the meat of it, right? Now, the first thing we'll do is just quickly design our gears, right? So let us see what we're working with here. Okay, so currently the center distance, which is, the center to center distance, is 40 millimeters. As for how big we want our claw, I mean, this isn't rocket science precision design here. It just kind of needs to pick up the stilt. Hello, claw gears. Let me, cancel out of you. Okay. So, realistically, it's got to be somewhere within these two bounds, which is 77 millimeters. Honestly, 40 is looking pretty solid as is, right? I mean, if we want to, make a little sketch here as a reference. And separate these out by 40 and have them meshing like such. Made them equal in size and had them horizontally aligned because I'm sideways. Actually, this kind of is a little bit big, not gonna lie. Yeah, we can make this a little bit smaller, to be honest. Like, I don't know, 32. Yeah, that honestly works pretty good for me. Not gonna lie. Yeah. Honestly, maybe we can even go a little bit smaller, like a 24. 24 seems pretty chill. Has a fair bit of space to that. Okay. Yeah, we'll finish that and we'll kind of delete that out. Yeah, because that was just a little reference drawing to get a sense of scale. Yeah. Let's go here. So that's not what I wanted. Let's right click and edit using Design Accelerator. Right, and for the record, in case I kind of went through really quickly, the way you make the gear is you first go into the Design tab, and then you navigate your way to power transmission, right? And then you click on spur gear, and it'll also make a few other different types of gears. Bevel gears, which are gears that go at a 90-degree angle. As you saw in the pop-up that showed up 2 seconds ago, that isn't showing up anymore. Hello? Okay, well, it does not want to show up for you guys. Okay, yeah, worm gears, which also kind of go at an angle, but it's a specifically 90-degree angle, and they're like non-back drivable. So yeah, these are some special types of gears that you can make. Here's your drop down that I was trying to show you guys. Yeah, it can make gears not next to each other. So that's convenient for certain applications. Anyways, yeah, so we're making a spur gear. I clicked that like I'm making another spur gear. I already made one. So we're just going to right click this guy and edit using Design Accelerator. Right, so now we have this menu here, and this has a lot of numbers and geometries about these gears. Right, so now something we want is, so I'll kind of explain roughly what most of this does that you care about. This gear ratio is what we described earlier, the ratio of the teeth between each gear, right? So, if this has 10 teeth, this has 10 teeth, then the ratio is like 1 to 1. If this has 20 and this has 10, the ratio is, 2, etc., etc. So we're looking for 1 because of that whole mirrored motion thing. The module is the distance between, 2 teeth roughly. Or rather, it's like, it is not actually the distance between 2 teeth, but it's like synonymous with the size of the teeth, essentially. I am no expert in gear geometry terminology. Well, I used to be, but I took that class last year, and well, I haven't thought about it since. I usually use like a chart when trying to remember. But anyways, usually the exact size of a gear tooth does not, disturb me unless I'm designing something precise that requires, a lot of technical knowledge and like I have to worry about, gear teeth breaking. Well, that's not something you need to worry about today. So, yeah, let's make the center distance like 24. Right, and let's hit OK. So something like this is pretty good. Yup. Now, something we can do to improve these gears is, let's go back in here. So one issue about gears is that when they contact each other, there's a little bit of, as you can see, this contact is not perfect, right? There's a little bit of the geometry tends to either overlap or be slightly too loose, etc. And that causes something called backlash, where there's a bit of like wiggle room between two gears, right? So the way we can do that, we can prevent that, is, well, let's have this open itself, is we can actually put a bit of a helix angle to it. A standard one would be like 15 degrees, and you'll see what that does to it. creates that little bit of a spiral. So these are called helical gears, and they mesh a lot smoother than normals for gears. So the downside to them is that they're harder to manufacture, like out of metal and stuff. But for a 3D printer, this is easy work. So whenever you're 3D printing, you'd always use gears like this. Except one flaw with these is that now there aren't even forces, right, in this direction, back and forth direction. So when you spin them, like one gear wants to go to this side, the other gear wants to slip this way, right? Because they're no longer straight gears. So there's one thing we can actually do to, help with that. And I'm just gonna add this real quick. I'm gonna make this a bit thinner because we'll make an actual edit to the whole part itself. So let's make this like 6 millimeters, sure, and kind of arbitrary. Again, this is an internal comp robot. This doesn't need to be rocket science. Okay, now let's open you, right? And what we can do is make a little mirror right over you, and you'll see this little V shape. And what'll happen is if we let's open you up again, and let's get the next guy and do the same thing. Mirror. So something to note actually about mirroring in parts is that you can do in either mirror specific features, right? Like on the timeline you can mirror a feature, or you can mirror an entire body, an entire solid, like this, and that's what we're doing here. We're mirroring the entire thing across, right? And if we do that, I don't know why I keep clicking into there. Anyways, if we do that, we'll just update that. You'll see that now it's not just one helical gear, but essentially you have two helical gears, one mirrored over the other, that meshes into here, and these little, V's, they mesh into each other and sort of stop it from sliding, right? Because, this kind of holds it in place. And that removes the whole, axial, force issue where they slide off of each other, because now the forces are balanced because there's one on each side, and we still have that whole spiraled shape because this is the same geometry, it's just flipped over, right? So you still have that good clean meshing strategy whilst it's also not trying to fall off of each other. So this is called a herringbone gear, and these are really convenient while 3D printing. So yeah, anyways, now off of that, we'll just kind of make a quick little claw geometry on them. It doesn't have to be anything crazy, and in fact, I'm not gonna do anything crazy because it's kind of up to you. This is where you guys get creative with it. Yeah, I'm thinking about how creative I want to get with this, which is not very much, to be honest. But anyways, yeah. Yeah, something like that. I'm not. Yeah, just I'm gonna give some very, very rough dimensions. Really, really rough dimensions. Not a lot of thought put into this because, this is again where you get. Let's just kind of make that equal. Let's make those parallel maybe. You know, give that a bit of some width. Make it like, 10 millimeters wide. Something like that. I'm trying to geometrically define everything here, because although the geometry isn't too important for me right now, I want to be able to, properly mirror it to the other part. So, yeah, I'm just gonna, give it some dimensions so I know how to, reference everything. So, yeah, we'll finish that sketch. Bring that and kind of bring it across around here. And make sure that's a join. Something like that. This is a very terrible looking claw, but it gets the job done. Anyways, yeah, let's do a quick little save of that, and then kind of go here and kind of I just accidentally clicked on Discord and my browser and everything. Okay, anyways, and kind of do a bit of the same of that. We'll open this up, kind of see it, and I'll actually kind of just copy this sketch into here so I can like use this as a visual reference. Yeah. Anyways, let's see. Let's start with you coming out a good, 10 millimeters, which we'll dimension in later. You, and there's you. You guys are parallel, I know. And also 10 millimeters apart, I know. Now you have a height dimension of 56, and you have a total dimension of 48, which is weird dimensioning practice that I'd have one at a slant and one vertical, and this is complete nonsense, but for the sake of symmetry, let's just kind of quickly define you to be 24, and then I defined you to be 80. What am I missing? 10, 56. Oh, yeah, there's definitely something there. Let's see. Oh, probably the dimension for the hole. Yup, 64. Perfect. So that should be roughly symmetrical. Well, let's get this guy out of here also. All that just delete that. Okay. Now we can just extrude that out. There might have been a more efficient way to design that claw, but again, your problem. Yeah, and I'll save that. And I will come back to claw gears, and here we have that right here, the start of our claw, and I'll save that up. Right, now the next thing we will do is so the next thing, so there's two parts to our claw that we're gonna have to design, which is the way that it's mounted, right, and how it's being held together, and then also the servo connection. We can probably start with the servo connection, see what we can do. Yeah, so I'm just gonna open up from the kit. Let's go back to the project. Okay, journal comp kit. Right, see what servo attachments we have. I only CAD'd one of them for y'all so far. And not gonna lie, this isn't exactly the correct attachment for this, but we'll live with what we've got anyways. So let's say we want to connect it to this one over here, to gear 1, right? That's the one we want to connect our servo to. So let's pull up gear 1 1. So we have these holes. So this servo horn essentially will screw into a servo, which I guess I can pull up a model of that for your reference. Electronics, I think. Yeah, I'm pretty sure it's this one. Yeah, sure. Okay. So essentially, let's just put some lines on here. Yeah, this is a servo. This is what's spinning on it, right? And this meshes with, this. So you put this whole thing onto here, and that's how you mount things onto your servo, right? So, and this is called a servo horn. And then from here, you can mount stuff to these holes, right? So, yeah, this hole, they're 1.5 millimeters, very small stuff, but what you do is you take a screw and you essentially thread into the plastic is the whole idea. And, we have some screws for that, some M2 screws. Anyway, so yeah, so the distance between these holes is 2.5 millimeters. Okay. Okay, it's a bit bigger, 5 millimeters. Let's check across the center. 15. Okay. So if we go in, like, say, a circle around here, we can get 4 holes, at a diameter of 15 millimeters, essentially. Or, well, these, 2 millimeter poles, and space them out, 15 millimeters apart from the center. And, that'll help us, line everything up with the servo. So let's just quickly make a circle that is 15 millimeters. Okay, and now let us make our holes that are 2 millimeters a pop. Actually, we're going to make this 2.3, just 2.25, just to give it a bit of a clearance while printing, because when designing holes, when a 3D printer makes a hole as it's making its part, they tend to get a little bit compressed. So you want to add an extra 0.2 to 0.3 millimeters to your part. So yeah, that's the whole idea behind that. So yeah, 4 of those, and we'll extrude you out, and all the way down you go. Right. So after that, we can actually kind of start assembling if we want. So we can make actually a new assembly, and we can place our claw gears. Let's rotate this about the X right there and ground it at origin. Sure. Get some lines in. Right. And then we can also place in the servo horn and see how that looks. Though, actually, I just realized something, that we need to add something to that gear before we actually, connect the servo horn up. And I'll show you in a second. Servo attachments right here. So let's say we try and put this on here, right? Something you might notice is that if this is like roughly here, right, it would be rubbing against here because this would be screwed in flush with this. So in order to fix that issue, what we can do is just raise the where the connection is here. So let's just open U and create a little sketch here, and open you up a bit. A little bit of this, like something like short 18. Maybe like 20, whatever. It's not. It actually is kind of important. I don't know, like 17 to 18. Sure, 18 works for me. Okay, yeah, let's just also make sure to include each hole. And you know, just bring that up by like a millimeter or two, you know. Yup. And also something I forgot to do is leave some space for the screw heads to go in on the other side. These you know, claws are a bit of a tightly packaged mechanism. You know, just you want them in general to be small and, like, you know, well put together. So something I forget if I've talked about this, but you can use the hole tool H to, you know, add a little bit of a counter bore to, you know, these holes here. This is the complete wrong size. We want this to be 2.25 hole. I mean, this diagram is pretty self-explanatory. And then, you know, you want to put a little seat here for your screw head, which will happen to be about pretty sure it's like about 4 millimeters. And I think it's actually a little bit less, but like whatever. And then this will be like 2 millimeters, I'm pretty sure. Yeah. Honestly, we can try and get away with like 3.7 and try and make the little like fringes a bit smaller. Yeah. So we don't have to, you know, cut into that gear tooth so much. Honestly, we can make the gear slightly bigger and it'll kind of get rid of this whole problem where it's, you know, cutting into the teeth itself. So let's just kind of go in here. Again, we kind of arbitrarily picked the gear size, to be honest. It's not too important for this design, so let's just make it bigger. Let's make it bigger. Let's just choose like 28. Okay, well that clearly messed with this whole setup. Well, it's probably fine, but let's see. I mean, like realistically, what you can do is always just like, you know, use a different teeth to mesh these two, and that you can line them up straight essentially. So this isn't really that much of a concern. It's just that like the reference, you know, horizontal is different between the, you know, two teeth essentially, the two gears, which is why they're, you know, at a weird angle. But if you, when you assemble this, if you say put, you know, this tooth here, they would be straight essentially. If you notice that. But yeah, this will be fine. It's not that deep. It's not that important. I don't really care. So anyways, yeah, we'll leave it at that and go back to our assembly over here. Or whatever. Okay, now I just realized this is assembled upside down. Yeah, we can cut and we can kind of just place it again and flip it over this time. Claw gears, and let's rotate over the X, and that's upside down. Let's rotate over the Y, and probably do that again. And now it's right side up. Place that at the origin. Okay, so now this can, you know, go onto there now. So let's get you right up onto you. Not gonna lie, I could make this circle a bit thicker because this is a pretty small edge. So let's also go back to you and edit this to be like, who knows, like 20. Just to give it a bit of extra meat, make it a little bit stronger. You know how it goes. I can also make this a little bit bigger now to make it more comfortably bigger than the screw head size. Okay, now let's update everything, and let's now put you in the holes. So you to you, and you. Wait, this is in fact 2 millimeters, right? 2.25. Okay, sure, whatever. And then you to you. Perfect. So now when the servo spins, it'll spin this gear, which will spin this gear. And something I just noticed is that they're different tooth sizes. Let's go and open you up. Right. Let's edit this this thing using design accelerator. You see it says 13 and 14. So essentially what it's doing is you have a desired gear ratio and it's trying to match the center distance, but for certain center distances there isn't an exact gear ratio that it can comply to. So it kind of makes the closest thing, right? So it's trying to be 1-to-1, but there's no possible geometry that'll let it be 1-to-1, like this. So it kind of gets the next best thing teeth wise, makes it off by 1. So we can kind of fiddle around with the center distance until we get something we want. 13 and 13 works for me. 27 is a bit of a weird number, but whatever. Okay, yeah. This works for me. Save that. Come back over here, and everything's all good and well. Amazing. Now it's the housing for this whole mechanism, right? How this is all held together. So the first thing to note is I guess how we're mounting the servo. So the servo will be screwed in through this hole, right? You'll screw through there, and I closed the file for the servo. Let's just put the servo back in. It's in the kit, in electronics, right here. Yup. So you'll screw into the center of the servo spline. So what we can do is put you into there. Let's see how that looks. Something like that. Right, and then we can center it because it's centered, right? And currently what we have to do is mount this whole servo above it, and we also need to support this guy. So the way we generally do that is we have plate up here, plate down here, right? So to start off with, let's take a look back at our chassis lid setup. Right, so in order to do that, first we want our claws centralized. So we want probably note that we're gonna have to dodge this transistor. So we probably want to move a bit upwards with our claw. So we probably have our base be a bit taller as we screw into it. Yeah. Yeah, note that I'm actually designing this on the spot. I don't have any notes. I'm kind of just freeballing this, which is why I'm kind of stopping to pause and think. You didn't really notice as much with like the chassis because, well, this is pretty standard stuff, but the claw, I mean, it's also standard, but I also want to, think about the best way to do it. So yeah, we probably have like a bit of a raised platform here, and then you'd have, little thing for these, claw gears to sit into. And we're gonna have little like round pegs that'll, fit into the bottom plate essentially. So it'll like be able to kind of like free rotate into there. And then this side will have a peg to hold it in place, but the servo holds it in place on this side, and we'll have screw holes that it'll screw into essentially. So let us start with the bottom plate, because that's a lot easier. Actually, let us start with the servo screw hole that I forgot about. So let us go back into here, go here. The servo screw, I believe, is a 3mm screw. Don't quote me on that. Actually, do quote me on that, because it's kind of probably my job to be quoted about this sort of thing. Anyways, let's just extrude that all the way. Not really. Actually, not really. We can use the hole tool actually again. H is the keyboard shortcut, if I didn't mention that earlier. And the bottom timer is 3. Well, actually 3.2 for that clearance I mentioned earlier, because hole compression. And this will probably be about a good, like, I'm pretty sure the actual number is 5.6 or something. I'll make it like 6 flat just to give it some space. Yep, and then make it like 3mm deep. Usually screw heads are about as deep as the diameter for metric screws, I've noticed. Not a hard fast rule, but a general rule. Okay, so anyways, now a servo screw can kind of go up and in through there. Yeah. So yeah, next thing we'll do is probably that bottom plate down here. So let's make a new file, right? And so the way we need to do this is we need to design to be able to connect to here, but also connect to the claw, right? Or we could actually, yeah. So let's make a little bit of a base. Just well, so it's 48, not 40. I mean, it's 27mm apart. So if we look at that width, right, this is like the center to center distance. We need to make it a bit wider so there's space for a hole. So like 36, maybe like 42 is good, and then we'll make this I don't know, 24. Again, these dimensions aren't awfully like important. And raise that by a good like 8mm, sure. And I'm actually gonna cut the holes out of the corners. Because then we can just screw straight into the metal, and it makes our lives a little bit easier. Let's just do one of these, kind of like what we did earlier with the rectangles, and then we, actually what we can do here is we can do a bit of an offset, where we take the outer geometry, offset it in by like 2mm or whatever. Now we can create our hole, which is a 4mm hole. I clearly did not estimate that right. We could make that something like that ish, right? And then we put one in each corner. And no, I remember that whole like clearance thing. We should add an extra 0.2 to each of these holes, right here and here, right here, and we got one right here. Brilliant. Now let's make these constructions. Right, let's do that. And let's make all these countersinks. And 7.6. How does 8 look? 9. Sure, perfect. I just kind of wanted to cut out the whole corner. You can be 4. And then you can be 4.2. Brilliant. Now we can sort of, make this look a little bit nicer. And I forgot this corner. Let us include that corner. And then again, we can remove some sharp edges, put some fillets. This is purely aesthetic. Just to make it look nice. Perfect. Now we can save this as the claw base. Right, and now we can put the holes in. Right, so this had a 27 center distance. Right, so let's say we have little pegs of 8 millimeters. Again, kind of an arbitrary number, but 8 millimeter diameter pegs are pretty stable. I mean, this is something you kind of come up with some experience in designing for how stable something is, unless you want to make an actual simulation, which, if you're on the mate team, right, the external comp team, you might be expected to do, simulate the forces and stuff. But, for now, we can just kind of guess. 8, and let's just kind of screw that all the way through. Again, we should probably account for those, those expansion, extra, thermal expansion, which is actually why the thing expands. Because I mentioned that when you 3D print something, it expands a bit. It expands because of heat. But yeah, let us make this slightly bigger to correct for that. Slightly bigger. Again, note you don't want this too big, because you want it to fit snugly so that it spins in place, but you also want it to be loose enough where it kind of also free spins. And now let's go make our pegs. So yeah, so we're gonna do the second gear, and we're gonna make a little peg here. This 8, we'll make it 7.9. He's again counting for that expansion. Yeah, we'll do this. It doesn't really have to be that tall, I'm pretty sure. We can adjust this height later. And I'm going to mirror this to the other side, if it can be mirrored. And it cannot, because, well, it can if I make a mirror plane, because the plane that I selected was on this face. That's on the origin plane for that axis. So let's just make a plane between these two planes using this mid-plane tool in the work features, and we can just make a mirror across there. Right, so just mirror features. So now this is one of the feature mirrors, right? So it's not one of the actual whole body mirrors, just the one feature. This honestly looks a bit tall, not gonna lie. Yeah, that should do. Okay, let's head back. Let us this, and let's import. Did I save the base? Yes, I did save the base. Let's also X out of some of these, just so that we have some extra space in this bottom bar. Also, let's X out of this. We don't really care. This is just a a drawing for you guys to just kind of get an idea. Okay. Yeah, let's claw base. Right, let us go into this assembly. Place you. Yeah, okay, I'm thinking about which folder I put this in. Okay, right here. You know, for the record, if I feel a little bit slow right now, if y'all think like I'm working a little bit slowly right now, that's in fact because I am working very slowly, because it's like midnight right now. It is in fact 1 a.m. I'm kinda out of it, but you know, we're here now, so yeah, that's the context for why I'm kind of a little bit on the sluggish side right now as we're designing. Anyways, yeah, let's do this. Right, line you up to this guy. Right, bring you down now. Line you up to this guy. And note, if we have these two kind of like flush against each other, it causes a lot of friction. So what we'll do is actually open you, and I honestly don't know which side's what. So I'm gonna guess it's this side. And then we're gonna make a slightly, wait, where am I making my, oh, whatever, it's fine. And then make this a little bit like something like that. Just a small little lip. Hello, did I hit escape? Okay, there we go. And we're just gonna extrude that out by like 1 millimeter. It's not that deep. And then you kind of do that same mirroring thing across. We'll need that for the other side. So remember how I was complaining with the whole sides thing? It doesn't really matter. It happens on both sides. Yeah. Anyways, let's look at this assembly again. Right, now we can take this face, which is a lot smaller, which means when I rub it against this face, it's not that bad. Right, so it's something like this is what our claw base is looking like right now. I'm also gonna hide this one plane now that I don't need it. Just Alt V and save you, so I don't have to, you know, see it in my face. Yeah, this is where we're looking right now. I'm gonna actually save this before like something happens. Claw assembly, sure. Right, you know, always save as you work. Okay, so next thing, I'm actually gonna flip this over, just, you know, to make it look a bit neater. Right, because, you know, if I want to design where my servo is gonna be in this design, I don't want it off in the middle of the side. I want it, you know, more centered. Right, so something over here. Right. Right, and now what we can do is, before we forget, we can put some mounting points on the lid actually for this. So this is 18 by 50. Okay, 18 by 50. Let us open the lid of the chassis. 50 by 18. And first we want this centered, because that makes your life a lot easier. And then probably a certain distance away from the edge. Let's just say like 16. Pretty arbitrary, but yeah. And let's put the holes in the corners again. This time though, note that we're screwing into this metal part. And the way you make threads into metal is, instead of putting an insert, you actually just cut the thread out of the metal, and you make the hole a little bit smaller so that you can cut that little, you know, spiral thread out for the screw to go into. Right. So for M4, the threading hole size is 3.3 millimeters, because the pitch of the screw is 0.7. So you take, 4 millimeters minus 0.7, you get 3.3. Yeah. Or you can just kind of look it up if you don't feel like looking up the pitch. So, yeah. Anyways, let's just make all of this hidden right over here. And I already lined up this whole rectangle. Okay, so yeah, let's finish the sketch. Let us extrude you out and down. There we go. Now technically this doesn't really do anything in Inventor, but there's a thread tool to make a visual graphic of threads. It doesn't actually model the threads. This is just like a picture, a design little thing. It's a texture of a thread. So it's actually marks where the threads are in your CAD, which is pretty convenient for me. If I'm like, machining your part, I can like see where you intended to have threads. If you give me this as like an IPT file, which is, the Inventor file type, I can open it and see, he wants threads here, So that's where this kind of comes in handy. It's a graphical tool. Okay, so yeah, we'll save this now. And what we can do actually, we have our claw assembly. We can just import our lid into here and just kind of mount that on and see if everything looks right. I just realized I put the wrong screw into there. Yeah, this will be the front side. Yes. Visualizing is hard. Oh, I'm pretty sure this one would go to this hole. Yes. Brilliant. I'm a geometry expert. Okay. So yeah, here we go. Right. So now next thing, we have to do the top plate. And after that, we're like essentially done. But yeah. Not gonna lie, we don't even really need to do this in terms of plates. We could make this one solid piece, not going to lie. Yeah. Right, if I actually extend this out the back and kind of come up and around, it might make our lives easier than having to connect multiple pieces together. Right, make it a little bit more rigid, etc., etc. So actually, I'm gonna first of all kill these back two fillets, and after I do that, I'm gonna double check that that's the back, because it's kind of hard to tell. So let's just check that that was not the back, that's the front. So that's why we do these checks here. So let's take this again and go here and here, and honestly, let's just kind of kill you two as well while we're at it. Yeah, actually, I kind of like those two fillets. They looked kind of nice. I don't know. It's not important at all in the slightest. But anyways, let's go back to this assembly. Not gonna lie, this is gonna have to be a bit wider for this to kind of climb out the back. But we can do that. We can do that. Let us just edit the sketch. Make this like 36. Who knows? It's not that important. It's not that deep. Let us go here. Well, clearly that didn't work out as I thought. 28, 32. Yeah. And then open U. How does this work out? 32. Let's see if everything lines up now. Well, clearly, okay, I messed up somewhere. Is this still 16 away apart? That is 26. Okay, let's update that. The lid, let's go make you 26 apart. Let's go back to the assembly. Okay, perfect. Now, honestly, this isn't much clearance at all. I'm gonna make this just ever so slightly wider, just to make it a bit more comfortable. 34, which comes out to a good extra 2 millimeters, 1 millimeter, 28. Yeah. Let's go back to the lid. Make this like 28. Yay. Perfect. Okay, claw assembly. Update you. Right, now we're gonna make this kind of wrap around. So we'll make a sketch and we'll kind of just make a rectangle here. And we'll, kind of make you go here. Shoot, wrong thing. Use our coincidence straight to go to this corner, to this corner. And I missed this to this. Okay. Now we'll measure out a bit of a height that needs to go. So essentially needs to, go from here to here essentially, right? And then a bit of extra height to, hold in everything else. So this needs to be 14 millimeters up. Yes, 14 plus an extra like 4, 5. Yeah, because I'm including the thickness essentially. Or I mean, it doesn't really matter, but whatever. You can design it around it. Okay, so let's make this 19, right? And we're gonna. I realize I sketched this on the wrong side. I'm a clown. I gotta sketch it on the back. Okay. Anyways, no one saw that. None of you guys. Let's just put you to you, and what did I say? 19. Just go like, something of that sort. And honestly, I'm not a fan of that fillet anymore. I'm cutting those out now that I see it. Yeah. I just realized that this whole kind of is not working out now that this is in the way, to be honest. Let's just quickly carve out a little, just a little something. Just to make sure that there's no space for the screw head to sit in, now that we've made these. Just a little thing this way. So this just puts some space on for the screw head, is what that does. Okay, perfect. Now, what we can do is let's check something. I clearly missed something. Let's make you 3 millimeters. Okay, 3 millimeters more. I think I measured from here instead, and then I dimensioned from the bottom. Which, to be fair, in my head I thought I would dimension from here, but I forgot. So, you know, it happens. Let's just where is it? Add another 3 millimeters to this. Wrong extrusion. There's this one. Wrong dimension. Okay, 22. There we go. We're making it eventually. Okay, so now let's first of all project this. I'm pretty sure it's this is the front. This is our claw assembly. Right. Let's just kind of flip this around. This is the front. The one with the pegs is on the right. Yeah. Let us go back to here. One of the pegs is on the right. So we can do that and do this, and then this one needs to be a lot bigger to give space for the servo horn. Yeah. And then note that we'll have this whole thing coming back out. Honestly, we'll just project all these geometries and they'll sort of connect themselves. Not gonna lie. Yeah, I can just do that and then do a little, what would I even dimension this like? 23? Who knows? Yeah. If I go up by like 4 millimeters and include this. And then we go to the claw assembly. Let's check this out. Up at the front. Let's see this. Oh, well, this is still clipping, which is not great news. Not gonna lie. What we can do is, for one, we can kind of just cut out this whole section. It's kind of unnecessary. So yeah, honestly, that's what we'll just do. But also, I'm going to take a quick measurement and kind of see how big this is. This is a whopping 31. Let's just say 32 millimeters. Let us open our claw base back up and let's see. 32 looks like that. So let's just kind of do something like this and just project all this out. And we can probably just cut off the whole section. Why isn't that dimensioned properly? Hello? Okay, yeah, let's make sure that that is tangent to the edge. Perfect. Now what we can do is just kind of cut out the entire section for fun. There we go. Honestly, I should probably also have it cut horizontally here. Not gonna lie. Yeah, something like that. Right, and make this also tangent up with that. Perfect. And then we can cut this out too. That looks kind of weird. Alright, now we can also fill this out to make this look a bit nicer. Oh shoot, wrong one. Yeah. Looks a little blocky out the edge, but you know, it happens. Put a bit of a fillet here. This fillet's actually functional because adds a little bit of meat to this little dimension over here, right? And you know, meat's important. You know, keep it strong, etc. So yeah, there we have that. Save this. Let's go back to our claw assembly, and let's unhide the base. And we'll see where we're dodging this guy comfortably, right? And now we have a little thing for our peg to go into. Oh, something I've noticed is I actually cannot build this because this top section does not separate from the bottom section, which is interesting to note. So actually, we can't make this one solid part, which is, well, you actually can if you do a print in place, where essentially you print this as one part, and you could actually just leave it at that. But I wouldn't personally try it. Well, yeah, no. So, slightly back to the drawing board, what we can actually do is say, delete this whole section and kind of remake it. Right, where essentially we put some screw holes up on here. First of all, actually, let's make this a bit thicker. No, that's not what I was looking for. Let's make this a bit thicker, like say 10 millimeters, like we did with the chassis. So we can put some heat set inserts in here. Right, yup. Now, yeah, perfect. Now, if we're really rich, I was going to say that we could actually machine this all of aluminum and it would have been really cool. Thing is, we're not that rich, so we're not going to do that. Also, that would have been really heavy. Anyways, 5.6 millimeters for, you know, heat set insert. Let's dimension this relative to the center, so let's just get a reference line here. Here to there, right. Hidden, no constructions, right over here, like such. You know, make this like 16 and make it align to the center, and we can mirror you across. Yup, right over there. And then we can extrude you down over like such. Perfect. Okay, now we can make a new top part to our lid. So actually what we can do is that whole deriving thing that we did earlier with our claw now. Wrong folder, bro. Okay, claw, right, claw base. Now what we can do is come back here, start a sketch here, and then we can project the whole, I guess the whole bottom will have a big face, right? And we can actually just cut through all that, and then we can share the sketch so that we have some geometries here. And actually what we can do is we'll keep the right one because that's the one with the peg, and then the other one, what we can do is we can, if I remember correctly, it was 32 out. And then I had it come in, probably also have to have it come in at least, well, first of all I need this horizontal, And then I need this to come in. Am I crazy? I think this ended up snapping to something while I was dimensioning. Yeah, anyways. So 16 from you. Yeah, 16 from there, and then we got a good old 16 from here, and that makes a diameter of 32. So we can now extrude this up. Also, I noticed that I did not project the two holes that I did care about, which were these mounting holes. The rest of this can kind of just all go. Have fun. Yup. Now we'll extrude this bit up here. 6 is good and stable. Fill it out these corners a bit, make it look nice. What we do around here. Probably not these back ones. Okay, we'll say this is claw top. Plate, whatever. Now go into the assembly. Actually, before we do that, first let's exit you, and then here, let's just hide this for the sake of our sanity. Alright, and come back into this assembly, and then place you. You did it. No, I didn't place it yet, I just made this part. Claw, place, claw top plate, right, and then put you right over here. And then something to note, actually, I just remembered, is I need screw holes for, the actual, servo. So we'll actually have to, CAD those in a sec. Something like that. And then also need to actually connect it with the screw holes. Right. So there's that. Now we have this all lined up. Let's just take note that we'll have to dodge this. So what we can do is we can fill this section up just all the way up to here. So we'll need to take careful note that we have 3 millimeters to work with. Though actually we need to make this whole thing up here. So actually it doesn't even matter. We have 8.1 millimeters to work with. We are beyond chilling. So, yeah. Let's just... I'm thinking, okay. Yeah, I would say we start with making a platform to cover that 8.1 millimeter distance. So first thing is we'll actually kind of redefine the other geometry for the other hole. So make you here. I don't really care what size this is. What size is this actually? 8.2, whatever, we'll make it 8.2 for the hell of it. It doesn't really matter. It's a reference geometry, right? And then we will align you up to here, and then it'll be, 27 center distance. So this is the center point, the reference of everything, right? So now let's actually open up a CAD file of our servo. Right, so now we'll just make a sketch to do some measurements on. So let's just project you and you. right? So, as a note, this is a good 11.13 point. I can't read. It's way too late. Okay, so 13.9, and then this one is 5.1. Okay, and then let us measure the hole distances. That is 47.8. This will be 10.2. That was earlier 5.1. Yup. Okay, so 10.2 by 47.8, I think. Let's go inside to inside. 49.395, depending on what you're measuring to. If I go outside, 47.8. I'm going to trust the actual inside number because that's the actual hole. 49.395. Perfect. Okay, so let us make a little 49. Let's make a center rectangle. So 10.2 by 49.395. Right, so this is our servo hole sort of thing. Right, so we need a platform essentially above this so that, we can reach this. And then also note that this would be over here and this would be, what did I measure earlier? 13.9. Let's go back over to the servo. 13.9. Yup. So let's go to where even was I? Oh god, the claw lid, claw top plate. Okay, so yeah, 13.9. So this is roughly where the servo is located. This is all reference geometries, I guess, for the record. This has nothing to do with the actual. I just need to make actual material up here. So first, let's bring you back, and then I guess let's just bring everything back. But we need to make this just a hair longer because we need to fit in all of everything, including four, M4 screws, like such. So we can give this a length. Let's make that 4, whatever. Maybe like 6, whatever. And then kind of give this a length, whatever. As long as it's in, it's in. We can fit a screw here comfortably, you know what I mean. Right, okay, so, yeah, we're here now. I'm honestly gonna make these all hidden, just so they don't cause any problems. Okay, so now that we're here, we can extrude this up a little bit. Yeah. By, what was it, 8.1? Okay. And then for our convenience, we can actually copy this whole, reference diagram to the next sketch, I'm pretty sure. Right. So if I put you on you. That was not what I wanted. Let's project this. And put you onto you. That's great. Now let's delete you and see what's going on here. You barely exist. And you, okay, fine. You do exist. Let's just give you an arbitrary diameter. Let's just put you back in here. Okay, and make you non-existent. Okay, now we got these two holes. Which we will make, no longer construction because those are real holes. And give this some clearance like I did earlier for other parts. Actually, these are heat set inserts because we were screwing into them. So let's actually make these 5.6. Yup. And then let's actually measure the servo's body out, which is a nice solid 20 millimeters. So let's make it 21. Just give some space. And then I didn't measure what the long waist dimension is. Let's take a look at that. Long here to here, it is 40. So we can make this 40.41, whatever. And we can extrude this, all of these all the way through, to be honest. Well, actually, we can. I just realized that I just cut out that entire thing, so actually, I'm just going to extrude this to this face and call it a day. And also note that this looks really thin, so we're going to extend this out in this sketch. Let's make that like 42. Add a bit of meat there. This looks a bit jank, but it honestly probably will work out. Let's just kind of see how it's fitting around. If you look at the claw assembly. I mean, there's more than enough space up there. And then let's say if I hide this. Yeah, sure. Then there's no space for the peg. Right, so nothing's interfering there. Right. And now if we look here, right, so this is screwed into here. This is spinning the claw. Right, so this gear is, fixed pretty well. If we want, we can actually put a peg on the bottom of this to help stabilize it. Because I did put a peg hole in, so we can quickly do that. Just, actually, I realized that this is screwing all the way through, so we actually can't. Yeah, no, we actually can't. Because we're putting a screw here. Or can we? We kind of can act. Whatever. There's another way to constrain this whole gear where essentially, so you can either use a screw or you can use a peg because essentially what I'm thinking here is that essentially the screw currently is holding it to, this servo, right? But let's say if you're holding this and you're screwing, this gear, into here, and then you have a peg down here that's, you know, fixed into here, technically you also can't move this at all anyways. So theoretically, you could get away with just using a peg, but it's really kind of up to you in your design. We're here now, so we'll just kind of keep with what we started with. So we're essentially done with this claw, I'm pretty sure. I'm just kind of checking if there's any kind of like, you know, clipping at all, if it's hitting anything. And that back, is that clearance there? What is? It's pretty tight. I'm pretty sure that this is actually just the. Actually, yeah, there's a lot of clearance back there. We're chilling. Yeah. So that's a rough idea of how you would design your claw mechanism. This is a very rudimentary claw design that I made because it is in fact 1:22 a.m. and I designed this on the spot. Well, we'll try making this look nice a little bit. Add some fillets, add some flair, you know. Because why not? We're here. We are very much here. Okay. Yeah. Sure. I'm just gonna save this now. Yeah. It's also X out of you. X out of some of these ones. Right, we did it, and now we'll kind of put this all together in an assembly. Right, so let's make a new assembly. Right, and then we can place our chassis. Right here. Okay. One thing we'll do with our chassis assembly is we're going to delete this because we already have it in our other assembly. Right, so back to this assembly. Actually, back to this assembly. This is the transmitter, right? Okay, there. Okay, so now we'll update this guy, and we're gonna place in our claw assembly. And now we'll sort of line up the holes. I guess you go there. And you go there. Right. And then you come up. And we gotta connect you up there. Like such. And that's where we're at right now. I realize that this is technically hitting the wheel, but you can design this to just be a hint taller, which, you know what, we're here now, we can just do that. In fact, just make this taller by like a few extra millimeters. Alright, let's just check this out now. Right, brilliant. We have lots of clearance. Okay. Okay, that messed this whole thing up. Because there's just some dimension that kind of like didn't transfer over properly. But I'm not really gonna mess with that right now because it's not that important. Overall, though, you guys sort of get the idea of how to design the sort of claw mechanism, and you can sort of fill around the dimensions to get that perfectly right. And even if you kind of copy this one for one, as long as you sort of make sure your claw's not touching the wheel, technically you should be fine. And this should be perfectly functional for you. So yeah, I'm gonna put some of this in here, right? Something like this. and you can use this, kind of pick up the tesseract and move it around.